Good morning to all. Today we can be discuss about that. To learn about thermodynamic principle of metal energy, thermodynamic principle, and also about the Elegum diagram. Okay. So here, try to learn this concept correctly, and also you must learn the observation. This observation point is important. You have 4 observation. At least you have to learn any 2 observation. Okay? Please all, if you take the note, we can be learn. Today our learning objectives to learn about thermodynamic principle of metallurgy and Elegum diagram. The extraction of metal from their oxide can be carried out by using different reducing agent. My dear children, yesterday we learned about that some of the metal oxides are converted into metal here by using some of the reducing agent. Am I right? For example, XIO, one of the oxide ore is zinc oxide. This on reacts with the carbon. That means carbon is one of the reducing agent. Carbon combines with oxygen to form zinc metal and carbon monoxide. And next one we learn about that chromic oxide. The chromic oxide on reacts with the carbon. We get chromium and carbon monoxide. Am I right? Carbon monoxide is a gas. Am I right? Here how to balance the equation. 3 oxygen is there, so make it 3. 2 chromium is there. Okay, now the equation is balanced. Next we discuss about that chromic oxide with aluminium. What is the formula for chromic oxide? Cr2O3. What is the formula for aluminium? Al gives Cr plus Al2O3. We are using one of the reducing agent is aluminium. Next about titanium oxide. What is the formula? TiO2. We are using one reducing agent magnesium. Magnesium combines with oxygen, we get titanium plus magnesium oxide. We have to balance the equation. 2MgO. Am I right? Next one about that thorium oxide. What is the formula? THO2. This one reacts with the calcium. Here we are using one of the reducing agent, calcium. Calcium combines with oxygen, we get calcium oxide. And also we get the thorium metal. We have to balance the equation. Calcium 2CaO. Okay. Like that, each one reactions we are using different reducing agent, not same reducing agent. Can you understand my concept? Here each reactions we have using different reducing agent. Anyway, today we have to learn about that thermodynamic principle of metallurgy. All of you know that one. One of the ore we are getting metal oxide. From the metal oxides, we are using different reducing agent. We get metal. Am I right? So, as based on this thermodynamic principle, which one is the best suitable reducing agent? We have to find out. Okay, by means of thermodynamic, which is the best reducing agent? Which is the good reducing agent? Like that we have to find out. And also one more point is the delta G. What is about the delta G? That is a change in free energy value must be in negative, high negative value. Okay, that's you have to find out. Okay, for that we are taking, let us consider one of the reduction of metal oxide. How the metal oxide undergoing reduction. I am writing the equation. One of the metal oxide, that is, we can written as MXOY, metal oxide, solid state is converted into metal plus oxygen. We have to balance the equation. Here oxygen having 2 on the product side, but the reactant side having Y. Am I right? So how can you solve this one? Means in the reactant side we can be give 2 Y by Y. So the Y we are cancelling. So we get 2 oxygen. Am I right? 2 oxygen. So reactant side also 2 oxygen, product side also 2 oxygen. Am I right? Now oxygen is balanced. What about the metal? Here now they are having 2 by Y MX. Am I right? So you can do convert like that. The product side also 2X by Y M. Now the equation is also balanced. Okay, it we can be mentioned like that. Equation number 1. This reaction, that means the metal oxide is converted to metal. That reaction may be carried out with carbon. We are using one of the reduction reaction by using carbon. One of the reduction, that is a suitable reducing agent. We are using here carbon. So in this case, the reducing agent of carbon may be oxidized to either carbon monoxide or carbon dioxide. It's a possibility. Am I right? I'm saying this possibility. What are the possibility? The carbon is converted into carbon monoxide or carbon is converted into carbon dioxide. Anyhow, here we have 3 possibility. What are the possibility? Number 1 possibility is carbon combines with oxygen, we get carbon dioxide gas. This is equation number 2. Am I right? And next possibility, carbon combines with oxygen, we get carbon monoxide gas. Am I right? Carbon monoxide. There is a second possibility. We have to balance the equation. Make it 2 on the carbon monoxide, then carbon also make it 2. Am I right? Next one. If the carbon monoxide is used as a reducing agent, this carbon monoxide is further oxidized to carbon dioxide. Okay, am I right? Suppose we are using carbon monoxide as a reducing agent. This carbon monoxide is easily oxidized. We get carbon dioxide gas. So this is also the third possibility. So what is the first possibility? Carbon plus oxygen give carbon dioxide gas. This is the first possibility. What's the second possibility? Carbon combines with oxygen, we get carbon monoxide gas. This is the second possibility. Third possibility, carbon oxide, there is a carbon monoxide combines with oxygen, we get carbon dioxide gas. This is the third possibility. Okay, anyhow, we get 4 equations. Now, out of this 3 possibility equation, we can be select any one is the best suitable reducing agent. We have to find out which one is the best one. Am I right? Which have the better reducing agent? Which one have the better reducing agent? And also the reaction must have high negative delta G value. That also we have to find. 2 possibility. Okay, sorry. Only one reaction we can be select. Not 3. Any one reaction we can be select. So a suitable reducing agent is selected based on the thermodynamic consideration. That's the important point. Here, the suitable reducing agent we can be selected. The suitable reducing agent we can be selected, but it should be based on thermodynamic consideration. Listen, all of you. We know that for a spontaneous process, the change in the free energy delta G should be negative. This is a spontaneous reaction. I read the previous, we discussed about the spontaneous reaction. What is about the spontaneous reaction? Spontaneous reaction is no one to be induced. Am I right? The reaction produced as their own accord. Okay. The reaction produced as their own accord. Okay. So, anyhow, the change in free energy, that is delta G, should be negative. Therefore, thermodynamically, the reduction of metal oxide, that is the first equation, that is metal oxide is converted into metal plus oxygen with the given reducing agent, maybe the reducing agent may be in equation 2 or in the equation 3 or the equation 4 can occur if the free energy change of the coupled reaction. Listen all of you, here the metal oxide, after we have to use one reducing agent, this reducing agent may be in the first equation, in the second equation or the third equation or the fourth equation. Anyhow, we have coupled the reaction. Coupled the reaction means joining the reaction. I'm right. In equation 1 and equation 2 are the equation 1 and equation 3 are the equation 1 and the equation 4. Anyhow, the value must be in negative. The free energy change, the free energy delta G value must be in negative. Okay. So, the reducing agent is selected in such a way that it provides a large delta G negative value, okay, for that coupled reaction. Dear children, anyhow, here the metal oxide is converted into metal. Okay, that time we must need one reducing agent. What is the aim here means, which one is the best suitable reducing agent? Which one is the best suitable reducing agent? Maybe the second equation or the third equation or the fourth equation. And also, if you are selecting the second equation and the third equation or the fourth equation, which one have the high negative value also? Delta G value, which one have the high negative? That also you have to find. Okay, that is as based on the Elegum diagram. Okay, it is based on the Elegum diagram. Anyhow, we are giving one formula. The change in Gibbs free energy for the reaction is given as the expression delta G is equal to delta H minus T delta S. This is, I think, that we learned in the 11th grade. Am I right? What is about the delta H? Delta H is about that enthalpy change. Okay, enthalpy change. What is about the temperature? Temperature means T. We are giving the temperature T in Kelvin. And about the delta S, that we have saying that entropy. What is about the entropy? Entropy means it is a measure of randomness or disorder. What is about the entropy? It is a measure of randomness or disorder. So, for an equilibrium process, delta G naught value can be calculated by using the equilibrium constant by the following expression. We are giving one expression. What is that expression means? Delta G naught is equal to minus RT ln Kp. Minus RT ln Kp. Here, Elegum used this equation for what purpose means? To calculate delta G naught value at the various temperature for the reduction of metal oxide by treating the reduction of equilibrium process. This is an important point. Heraldi, Elegum used the equation, that is what is the equation? Delta G naught value is equal to minus RT ln Kp to calculate, there is a relationship to calculate delta G naught value at various temperature for the reduction of metal oxide by treating the reduction, that is by treating the reduction reaction as an equilibrium process. He plot the considering the temperature in an x-axis, that is the temperature, you have two axes. One is about the x-axis and the other one is about the y-axis. In the x-axis, in the graph, he mentioned a temperature, and in the y-axis, the standard free energy change for the formation of metal oxide. Y-axis is given as the value is standard free energy change for the formation of metal oxide. Anyhow, by plotting the values in the form of graph, he got a straight line with the delta S as slope and delta H as y-intercept. Here how the intercept comes here. This is the value of 0, am I right? Maybe from the negative value. Start with a negative value here. The values are increasing. Anyhow, this straight line is touching on this here. So here intercept here, am I right? We know that the straight line equation y is equal to mx plus c. The change in Gibbs free energy can be written as delta G is equal to delta H minus T delta S. But what is about the straight line equation? Y is equal to mx plus c. Here c, that is y intercept. Mx, that is x means temperature. And m means delta S. Here, the resultant plot is a straight line with delta S as slope and delta H as y-intercept. Here we have one definition for the Elegum diagram. The graphical representation of variation of the standard Gibbs free energy of reaction for the formation of various metal oxide with the temperature. Can you understand? The standard Gibbs free energy of the reactions for the formation of various metal oxide with temperature is called Elegum diagram. Please all of you check the Elegum diagram. Here most of the metal oxide formation mostly they have the slope is positive, but there is only one slope, only one, that is a carbon monoxide. The formation of carbon monoxide, there is also a straight line with negative slope. Am I right? So others all, everything are the slope is about the positive. Okay. So this y becomes positive, why the slope become positive and why the slope become negative, that we can be discussed from the each equation. Am I right? Now we can be discussed about what are the observation of Elegum diagram. What are the observation of Elegum diagram? Observation from the Elegum diagram. Dear children, please all of you refer the graph. What is about the graph means, here this each equation shows that the metal oxide formation. Here most of the metal oxide formation, the slope is positive. Am I right? Here the slope is increasing. Am I right? The slopes are increasing. So it becomes positive. Here what is the reason means, oxygen gas is consumed during the formation of metal oxide. Oxygen gas is consumed during the formation of metal oxide, which result in the decrease in randomness. What is about the decrease in randomness means entropy. Entropy is decreases. Am I right? Decrease in randomness. From the beginning, the metals combines with oxygen. So we are adding excess of air, excess of oxygen and excess of heat. Here entropy first increases. Am I right? Next the reactions proceed. The entropy become decreases. So Whenever the oxygen gas is consumed during the formation of metal oxide, which result in the decrease in randomness. Here entropy is decrease, am I right? But delta S become negative, it makes the term T delta S is positive in the straight line equation. Here the decrease in entropy, it achieve a negative value and it makes the term T delta S become positive. How we can be write the equation? According to the change in Gibbs free energy, delta G can be written as delta G is equal to delta H minus T delta S. Am I right? Here delta S is negative. Am I right? Delta S become negative. So delta G is equal to delta H minus T minus delta S. So delta G is equal to delta H plus T delta S. This is the equation. So now delta S become positive. Am I right? So here what we understand means during the oxygen consumed for the formation of metal oxide, here entropy decreases. Due to the entropy decreases, it makes the term D delta S is become positive. That is the first observation. What is about the second observation? In the graph, the formation of carbon monoxide is a straight line with the negative slope. Please look the graph. There is only one metal formation which have the negative slope. I mentioned like that in red in color, am I right? Red in color, am I right? I mentioned like that. Here, the formation of carbon monoxide is a straight line with a negative slope. What's the reason means? First, we write the equation. What is the equation? C plus O2 gives 2CO. Am I right? C plus O2 gives 2CO. What is the reason? Because 2 oxygen is there when we are balancing. So how much carbon is there? 2 carbon is there. First, 1 mole of oxygen gas is involved in this reaction. How much mole of oxygen is there? Only 1 mole in the reactant side. Whenever it goes to the product side, they have 2 moles of oxygen. So no. So here the molecule is randomly increased. So entropy is also increased when the reaction proceeds. The change in entropy increase, so the slope become negative. What is about the equation? According to the change in Gibbs free energy, delta G can be written as delta G is equal to delta H minus T delta S. Delta G is equal to delta H minus T delta S. Here delta S is a positive. So we can be written as delta G is equal to delta H minus T delta S. Delta G becomes negative. Am I right? Please once again please check that graph. In the graph delta G goes to negative. First the temperature is nearly minus 300 degrees Celsius. Am I right? It goes to about nearly minus 700 degrees Celsius. What is happening here means due to the entropy increases. What happened? Due to the entropy increases. Don't forget that one of the small tips about that. When entropy decreases, Gibbs free energy increases. Can you understand the concept? When entropy decreases, Gibbs free energy increases. When entropy increases, Gibbs free energy decreases. Okay, that's the concept. Next about that, the third point, whenever the temperature is increases, delta G value for the formation of metal oxide becomes less negative. Don't forget that. When the temperature is increases, delta G value for the formation of metal oxide become less negative. And also it becomes zero at a particular temperature. Below the temperature, delta G is negative and the oxide is stable, and above the temperature, delta G become positive. Don't forget that. Below the temperature, delta G is negative and the oxide is stable. Below the temperature, delta G is negative and the oxide is stable, and above the temperature, delta G is positive. Here, as per this concept, the metal oxide become less stable at higher temperature. Okay, less stable at higher temperature. So the decomposition become easier. Here I am taking one of the metal is about that nickel oxide. Am I right? Nickel oxide. The nickel oxide, first it started nearly 480, like that. The temperature is about, what is the temperature? Nearly 480. It started, the temperature is 480 degrees Celsius. Next it goes to up to, most probably it goes to 2200, near like that. They are touching like that. Am I right? So here the nickel oxide are touching, near touching to the, that become at a particular temperature it becomes zero. Am I right? Here it becomes zero at a particular temperature. So the formation of metal oxide, first it becomes a less negative, a small negative. Nickel oxide, a small negative. At a particular temperature it becomes at a zero. Here below this temperature, the delta G value becomes negative, and also here the oxide is stable. Here the oxide is stable, and above the zero, and above the this particular temperature, above the zero, we can be say like that, and above the temperature, delta G become positive. Okay, below the temperature, delta G become negative, and above the temperature, above the particular temperature, it become positive. Okay. So after the zero, the nickel oxide decomposition is possible. When the decomposition is possible means at only at the higher temperature. Okay. When the decomposition is possible, higher temperature. Okay. Next about that, a phase transition. We are explained about the phase transition. That we can be see in the fourth point. Here we can be see some of the metal oxide at a particular temperature, there is a sudden change. Why this means? Due to the phase transition, there is a sudden change in the slope. Okay, there's a sudden change in the slope at a particular temperature for some metal oxide. Which are the metal oxide? Example, magnesium oxide and mercury oxide. Magnesium oxide and mercury oxide. Here a phase transition. What is about the phase transition? During the melting, we can be say the solid phase is converted into liquid phase. Am I right? Solid is converted into liquid. That we are saying about the melting. Yes or no? Melting. And liquid is changed into gaseous state. That we are saying evaporation. So anyhow, The sudden change is due to the phase transition. That may be in melting or an evaporation. That we mentioned here, there is a sudden change in the slope at a particular temperature for some metal oxide like mercuric oxide and also magnesium oxide. Okay, so what are the observation? First observation, don't forget that the entropy, there is a decrease in entropy, delta S become negative and make the terms T delta S becomes positive. Am I right? What is about the second process, second steps? Here, the formation of carbon monoxide, we get a negative slope. What's the reason? Here, due to the number of moles of carbon monoxide gas. Am I right? Number of moles. They're having 1 mole of oxygen gas. Here, 2 moles of carbon monoxide gas. There is only 1 mole of oxygen gas. That means the reaction between carbon and oxygen, we get carbon monoxide. But only 1 mole of oxygen gas is there, but because the product side is having 2 moles. So it indicates that the formation of an entropy. Anyhow, it indicates that the carbon monoxide is more stable. It's a very, very important point. More stable at a higher temperature. Can you understand? Carbon monoxide is more stable at a higher temperature. Next, about the third point, we are explaining about the nickel oxide. Don't forget that the nickel oxide. There is in at the border of zero, am I right? Below and above. Okay, that's a below and above. Below means we are saying that there is a delta G is a negative. The oxide is stable. Am I right? Below this temperature. That's a nearly zero. Zero below this temperature. We are saying delta G is negative and the oxide is stable. What happens above this temperature? Above this temperature, delta G become positive. So metal oxide becomes less stable at the higher temperature. So there is a decomposition of nickel oxide, nickel and oxygen. Nickel oxide is very easier, okay? And next about that, the last one point, there is a sudden change in the slope at particular temperature for some metal likes, which are the metals, magnesium oxide and mercuric oxide. Why? What is the reason? Because due to the phase transition, here suddenly the solid is converted into liquid for mercuric oxide, and about magnesium also, it is converted into gases. Am I right? About the evaporation. Okay, my dear children, today I am giving assignment about the observation of elegum diagram. Please write any 2 points about the observation of elegum diagram. They are having 4 points. I am not able to write the 4 points. Write any two points about the elegum diagram. Okay. Thank you all of you. Thank you. Have a nice day.